Hello wonderful person, this is Anton, and in today's video we're going to focus on our beautiful galaxy, the Milky Way. And specifically here I wanted to actually talk about our misconception of the way it actually looks, because today's pictures do not present Milky Way in the real sort of way that it actually looks. So hopefully you'll enjoy this video, and if you still haven't subscribed, click that subscribe button right now. Welcome to What Da Math. And so here we are in Space Engine, and I'm right next to Earth. We're going to escape from Earth and escape from our galaxy as well, just to take a look at what we see. Now, in this video, you may actually have to use a little bit of imagination, because even though I tried to recreate a more realistic picture of our galaxy using Universe Sandbox, I was not very successful because we don't really have enough tools to make it look the way it should look. So first of all, this is what Space Engine presents our Milky Way as, and basically all other galaxies kind of look similar to this, or most of them at least do. These are so-called spiral galaxies, and essentially it is a kind of a collection of stars with a central region that's slightly more dense than other regions, and you have these arms that come out from all the sides. This has been our understanding of how galaxies look for a very long time, up to about 2012, I actually think, or as far as I believe, because in 2012 we discovered something very unusual. Now, this was mostly related to the search for the dark matter. Let me just actually quickly go into the actual dark matter, just in case you've never heard of it. Basically, our galaxy spins, and you can kind of see that it spins just by the shape that it's forming. And as it spins, these different stars obviously orbit around it. But the thing is, the stars on the outskirts, including our awesome planet Earth and our star, the Sun, which is somewhere over here, seem to be orbiting a little bit faster than they should. Technically, if they're just orbiting the central black hole, they should not be moving so fast. They would be able to easily escape the galaxy, but for some reason, they don't escape, so something is holding them together. This something has been coined or called the dark matter. It's a kind of an unexplained phenomenon that we've been trying to find for a very long time. We still haven't been able to explain it. The most recent experiment in 2016 that was supposed to find it using neutrino detection capabilities basically failed. It did not find absolutely anything. And so for several decades now, we've found nothing. But we found something else that's a little bit unusual. As a matter of fact, this something is essentially all around our galaxy, to the distance of several 100,000 light years, so about this big. It's not shown here because it would be very, very dark and close to being invisible, but it is essentially a very large spherical cloud of matter. Specifically gas. Various gases, most likely hydrogen, although it's possible that it's some other gases as well. And this huge cloud, you can see in the picture right here, is essentially responsible for some of this unknown mass that is keeping us together. So some of the dark matter might actually be not so unusual or so secretive after all. It might be actually just be this gas that seems to make space not so spacey anymore. It's not as empty as we thought it was. So essentially, there's this gas cloud around the Milky Way. And interestingly, the total mass of that gas cloud is just as massive as all of the stars in the actual galaxy. So that's pretty interesting. The other thing we discovered about this gas cloud is that it actually also orbits in the same direction as the Milky Way. In this case, it's this way, at almost exactly the same speed, which is very, very unusual. It's just a little bit slower. And here we're talking about relatively high speeds. So basically, speeds of about 640,000 kilometers per hour. For the actual so-called halo, which is what this gas is called, and it rotates with the galaxy. And so there's this huge rotating cloud around our galaxy that seems to be sort of there, but we don't really see it as well, but it is definitely there. This particular halo is also one of the explanations for how we were able to find some of these stars that are actually on the outskirts of our galaxy. So I'm going to try to find at least one. If I get lucky, I might actually see it, especially if I raise the exposure a little bit. There's quite a lot of stars here on the outskirts, and we've recently discovered a brand new star that is even not in Space Engine yet, that has recently been born. It's basically a new star, and I just So there you go. There's a star right here. This is probably not the same star that I'm talking about, but it is a red giant of some sort that is on the outskirts of the galaxy. Now, how it got here, we don't really know. But if there was a halo, or I guess there is a halo, of gas orbiting around our galaxy, it could have formed from that halo. And so that young star that we've discovered is very likely formed by the gas from the halo as well. Now, this particular star that we've just discovered, the red giant, has a name of HIP 8549. I believe it is actually a real star, and it does have 3 or 4 exoplanets around it. Now, these exoplanets might be actually imaginary, but the star itself is real. So anyway, so that's one thing you have to imagine when you're imagining the Milky Way. It has the halo. But there's something else we're missing from the picture. Milky Way and pretty much every galaxy has these jets of really, really high-speed particles and also gamma rays extended in 2 directions. One you could call north and one you could call south. For our particular galaxy, they're not actually exactly perpendicular. They're a little bit mismatched. Here's the picture of what it looks like. They're basically kind of going this way. Now, if you were to look at our galaxy from far, far away, and if you were to actually look exactly at that gamma ray, our galaxy would be super bright and would technically be considered to be a quasar. This is what quasars really are. They're basically galaxies with these jet rays that you can kind of see. So yeah, there's these jet rays, or I guess gamma rays, that we have in our galaxy as well. And these gamma rays also form this relatively large bubble right here and relatively large bubble right here, known as the north gamma ray bubble and the south gamma ray bubble. So our galaxy is a lot more complex than we are used to seeing. So first of all, there's a really large halo of gas. Then there is these 2 jets, and then there is this bubble here and a bubble there. And that's what we've learned about it so far. This is how we kind of see it scientifically today. But I'm pretty sure that in the next few years, with the advances in science and detection of various particles, we will definitely change this view again, and we'll probably be able to explain the dark matter in a very interesting but kind of a more classical physics way, with some kind of matter that's possibly here and we just are not seeing it. So it's very likely that dark matter is actually just regular matter, also known as barometric matter, that is essentially somewhere here around our galaxy. We just can't really seem to see it. And I really hope that one day Space Engine actually gets some kind of an update that will also represent these galaxies in a more realistic way, because even though this looks very, very beautiful, this is kind of a more archaic view of what actual galaxies look like and what is really around them. So it'd be really, really awesome to actually see all of these other things like huge gamma ray jets and also possibly really, really, really bright gamma ray bubbles above and below the galaxy, and of course possibly some kind of a very dim but visible halo around it, because this is essentially why we have this unexplained mass that sort of prevents the other stars from flying away from the galaxy, even though they're moving a lot faster than they should. And so anyway, that's all I wanted to talk about in this particular video. I just wanted to kind of help you visualize the realistic image we have of our galaxy right now. So it's not really like this, and it's not really like this, but it is really like that, as you see in the picture. And this is essentially the view we have in 2016, and I'm sure this will definitely change in the next 5-10 years. Anyway, hopefully you learned something from this video, and if you have, don't forget to subscribe, don't forget to share this video with your friends, and don't forget to possibly comment on what else do you know about the shape of galaxies, or did I miss anything? If so, please post it in the comments below so we can talk about this in one of the future videos. I'll see you guys in the next video. Thank you for all of your support. Game you later, and as always, bye-bye.